Hello friends, welcome to my channel. Let's have a look at problem 2492, minimum score of a path between two cities. In this video, we're going to share a solution based on the use of disjoint set, abstract data type, or unified method. First, I'll read through the problem statement to digest the requirements. Then we do the analysis, and finally we share the routine code. First, let's look at the problem statement. We are given a positive integer n representing n cities numbered from 1 to n. We are also given a 2D array rows where road I is AI, BI, distance I, indicates that there is a bidirectional road between cities AI and BI with a distance equal to distance I. The cities graph is not necessarily connected. The score of a path between two cities is defined as the minimum distance of a road in this path. So we are required to return the minimum possible score of a path between cities 1 and n. So let's also look at the notes. First, a path is a sequence of roads between two cities. In the road is actually the direct edge, right? So the roads have the length is given by the distance. So secondly, it's allowed for a path to contain the same road multiple times, and you can visit cities 1 and n multiple times along the path. So this is actually very important. So this way, we just need to locate the corresponding components, connected components, and the minimal path in that connected components. The third one is that the test cases are generated such that there is at least one path between 1 and n. So in other words, the cities 1 and n lie in the same connected component, right? So with that said, we are ready to look at the examples. For example, in example 1, so this graph is a connected graph. So we just need to return the minimum road length, that is 5 for this problem. So in example 2, same, the graph is connected, so we just need to return 2. So before we look at the analysis, let's look at the constraints. First, the number of cities is in between 2 and 10 to the power 5. And the roads I has length 3, and each AI and BI is in between 1 and n. So AI and BI does not equal. So there are no repeated edges. There is at least one path between 1 and n. This is actually very important, right? Similarly, this one, the second note is also very important. So with that said, we are ready to do one solution first. So here in this solution, or in this video, we're going to explain the use of disjoint set, abstract data type, or unified. So actually we have a playlist on unified or disjoint set. So we have practiced quite a lot of problems using unified. So in this problem, in this video, we're not going to go into finer details. So we are going to directly do the coding. But for this problem, we just need to locate the connected component connecting cities 1 and n. Then the return is the minimum road distance for roads connecting nodes in this connected component, I will say. So for finding connected components, so typically there are two lines of ideas. One is using unified. The other is to use traversal, such as breadth first search, depth first search. So in this video, we're going to use unified. So another purpose here is to demonstrate that we need to interpret rack in a flexible way in union by rack, depending on the use cases. Like in this problem, I will interpret the rack being the minimal road length. Therefore, we just need to return rack the root of city 1 or the root of city n, right? So this is the overall logic or idea. So next, we are going to do the coding. So first, we are going to make some preparations. Let's see, we have a roots. So I'm going to use this dictionary, right? I for I in range, so 1 to n plus 1. So this will have terms like the 1 up to n, right? So the recs, so here I'm going to use the minimum root length as the rec for a certain node or city. So for this, I'm going to first use a very large one. Let's say float infinity. So for I in range 1 m plus 1. So with that done, so also we need to be able to easily track the distance. I'm going to use this aux, right? So it's a dictionary. So I'm going to use a tuple as a key, and we use the d as a distance. So for I, j, d in rows. So notice that here we are considering bidirectional edges. So we need also have gi is also have a distance d. But we just need to use this, and then we can use the dictionary get method to bypass this necessity of doing ij equals d. So with that said, we are ready to define the unifind methods. So first we are going to define the find method. So this is very standard, but here I'm going to use path compression. So not this path, but this path. So this is very standard. I'm going to introduce a result variable and then a while loop. So while result does not equal to roots of result. So I'm going to basically set result equals roots result. However, here I want to use some path compression. So I'm going to do root resets. So I'm going to apply roots here and roots here. So doing path compression, so we can use different formats. So you are welcome to check out the unifind playlist to explore more, right? So with that said, we just need to return a result after this while loop, because after this while loop, result will equal to roots result. So this is the union, this is the find with path compression. So next, let's define the union method. So ij. So this is also routine. So here I'm going to use union by rec. So I'm going to emphasize the rec interpretation, right? So let's first get root I or root j, right? So this equals find I, find j, right? So first I'm going to see if root I so does not equals root j, right? In this case, so we need to do a rec reset. So if rec root I is less than or equal to rec root j, and because we interpret the rec of root I as a minimal root length, so the smaller the better, right? So in this case, we are going to set the roots of root j to be root I, and then we are going to reset the rec of root I. It equals the minimal of its previous state, that is rec root I, and then we want to use the distance between the two nodes ij. So what we are going to do is that get, so we are sure that either ij is in the dictionary or gi is the dictionary, right? So we want to do something like this. We get this key first, right? If this key not in the dictionary, so we are going to use this get gi. So this is our way to deal with this. So otherwise, so we are going to do it in a reverse direction, right? So let me copy this part. So I'm going to set root I equals root j, and then we set the rec of root j. It will be the smaller of the initial one, and then the smaller the distance, right? So that's the union method. So here, let me also do another one. So if the roots I equals root j, so actually we can do something if we like. So we want to reset one of the recs, let's see, just to make sure. So we are going to use this one. Let's copy. Actually, we can copy this one. So we want to make sure that we use the minimal road length. So this way we finished the unit method. So once we done this, so we are ready to do the problem logic. So let's call it problem logic. So we just need to iterate over the dictionary or over the roads. Let's do over the road. So for V1, V2, this is the two cities, or city 1, city 2, and D in roads. So actually we don't need this specific one because that's in rows. So we do union operation. So V1 and V2, right? So this distance actually is retrieved from the dictionary aux, right? So once we done this, we are ready to do the return. By the problem assumption, so city 1 and city n must lie in the same connected component. So we just need to return rex, find, or 1. So this forms a solution format based on the use of disjoint set. So let's first do a special case check. Yeah, it passes example 1. Now let's look at example 2. Yeah, it passes example 2. Now let's look at the generic case. Yeah, it passes all the generic cases. So I guess with this said, that's about it for this specific problem. So here in this video, we explained a solution based on the use of union find method. So here what we emphasize is that we need to interpret the rec in union by rec, depending on the use cases. Like in this problem, we interpreted the rec being the minimal road length, which is suited to the problem. So with that said, I guess that's about it for this video. Thank you.